Welcome to Introduction to NSX Data Center for Security. My name is Alex Berger. I'm a product marketer with the Networking and Security Business Unit at VMware. We're going to talk a little bit about security. We're going to talk a little bit about NSX. Who here has never really had anything to do with NSX and is new to it completely? Okay, so we do have some first timers. So that's cool. We'll go over what do we mean when we say NSX, what is it. We'll talk about obviously its applications for security and how we can use it to bolster your security postures in your environments. And because I know that nobody likes hearing us marketers go on and on forever about all of these things, I have Matt Tilley here from Kinetic, a defense contractor in the UK. He's going to talk a little bit about how he's been using NSX in his environment and the amazing transformation that they've actually undergone in the last few years to get to a hyper-converged state. So he's going to talk a little bit about the real-world applications of this. When we get to the end, we'll do a little bit of Q&A if we have time. If not, Matt and I will hang out, and you guys can come and ask us some questions anyway. All right? So first things first. Right, this is anything I say here is not necessarily the truth slide. This is to protect me from my product managers, to be honest. So disclaimers. So before we get into it completely, who here is responsible for systems? So VMs, VI admin role, that kind of stuff. Okay, cool. What about networking? Network engineers, networking security. Cool. So what's very cool is this is now my second VM world, and I've had these conversations all over the world with people. And that number, when I ask this question, when I'm talking like this at conferences, continues to get bigger, which is great. We're happy to see that. Do we have any security ops, security engineers and architects in the room? Okay, a few of those. So I noticed a couple hands go up multiple times. Who here is responsible for all three of these things or some combination of them? Okay, yeah, cross-functional roles, right? That makes sense. So the reason I ask these questions is not just so that I can get a sense as to who cares about these topics, but it's because security is obviously becoming more and more a part of everybody's role, regardless of whether it's what you focus on primarily or what you're specifically tasked with. You could be looking after systems, the network, et cetera. You have to care about security, which is probably why you're sitting here today. It's starting to affect all of us. This is my dog. Her name is Tariel. She's named for a character in the Lord of the Rings movie, the Hobbit movies. And for those of you who have read the books and are holding it against me that she's not an original Tolkien character, the reason my wife and I decided to name her Tariel is because the actress who played this elf in the movies requested the largest prosthetic ears that she could get, which resonated with us when we met her. The reason I'm introducing you to Tariel is because as much as I love standing up here and talking to all of you and meeting all of you and traveling around the world and doing this and working for VMware in general, I love hanging out with her even more. And my wife. My wife made me promise I would mention her too. My wife as well. And anything I can do to make my life easier in the office, any technology, any process that I could use to make my world easier and more effective and efficient and do my job better, so that I can get home and hang out with her quicker, is a good thing in my book. And there's a big perception out there that NSX is going to automate away jobs, or it's going to make life more difficult, or add a layer of complexity, or something new that you have to go and tackle. And that's not the case. NSX is a tool. It's a tool for you to use to hopefully make your life more effective, more efficient, and better so that you can get home and do the things you like to do with the people or animals that you like to do them with. So that's just a point I want to make before we get started. Now let's start talking about security. Who here is familiar with the zero trust model? Okay, a handful of people. Least privilege goes by another name. That's the older kind of more legacy concept. So zero trust is a model that was created or institutionalized, I guess you could say, by a guy named John Kindervag, who worked for a analyst agency or an analyst group called Forrester. And basically, zero trust says that all network traffic should be untrusted. We should never trust anything, any communication. And we should only allow communications when we know for a fact that they should happen, right? This is least privilege. It's one of the oldest concepts in security, But John turned it into a model and put a name to it, and now we've started using that name in the industry, right? And this can be applied to network traffic. It could be applied to users, right? Identity management is basically this. Nobody should have access to data that they are not specifically supposed to have access to. And most people believe that zero trust as a concept, as a model, is probably the most effective way to secure an environment. If you can do zero trust, you have done the best job you could at securing your environment. But this is really hard to do. That's the catch. Operationalizing this, actually getting to this state, is incredibly difficult. And if you think about the way our environments look today, right? We have a bunch of workloads sitting out there. They could be VMs, they could be bare metal servers, they could be containers, what have you, right? It doesn't really matter. Cloud workloads. We've got a bunch of shared services, and we have a bunch of users. And yes, this is a little bit oversimplistic in terms of its representation, but these are effectively the components that we have in our environments. And if you think about the way we secure all these workloads living in the environment, we do it like this, right? We align, we create these macro, I guess you could say, segments, these large segments, aligned to the environment. We say, here's a web tier, here's an app tier, here's a DB tier, and here are all the workloads that go into that tier. But this isn't particularly zero trusty, right? Because in the end of the day, all of the workloads in that tier can communicate with each other whether they should be able to or not. And those shared services traverse those tiers, right? Because they have to in order to do their jobs. So this leaves us a little bit vulnerable, because if one workload in a tier falls, the entire tier falls. And we at VMware believe that as long as we continue to align our security policies to our environment, rather than the applications themselves, the applications that we actually want to protect, right? Because ultimately that's the goal. We're going to be a step behind in our fight against attackers. And we're constantly going to be playing whack-a-mole. Is whack-a-mole a thing in Europe? Do you guys know that game? Yeah? Okay. Just curious. So what would this look like? How do we move from this model where we're aligning our security policies to the environment to a model where we are enforcing zero trust on an application by application basis? Well, the first thing we need to do is we need to learn where in this picture our application even lives, right? Because that picture without the dotted line could be one application, could be many applications, we really don't know. And learning the boundaries of our application is a significant challenge, right? What constitutes our application? Which workloads actually make up the application? How does that application communicate across the environment? How do the workloads within the application communicate with each other? What processes are causing those communications at the workload level? All of these details are things that we want to learn and understand about our applications. And the reason we care about understanding all of that is because once we have that information, we can turn it into policy. And we can enforce that policy at the network level so that this application is not communicating with anything it shouldn't be communicating with outside of it, right? Now, we've got a model where if a workload falls within a tier, the application is still safe because we know that we know where the application resides, and we've begun enforcing network security policies to limit what this application can talk to based on only what it needs to be able to talk to. And that's the catch, right? This is essentially micro-segmentation, right, as we've talked about it in the past. Being able to enforce network security policy on each of those workloads to prevent them from communicating with workloads that they don't need to communicate with. But this is an incomplete picture. And the reason it's an incomplete picture is because right now this application can communicate with nothing, which is not helpful, right? Obviously, it needs to be able to communicate with shared services. It needs to be able to be accessed by users. It needs to potentially communicate to other applications in our environment in order to actually be effective. So while enforcing network security policy around the application and cordoning that off is extremely helpful and reduces our attack surface considerably, it can't be the place we stop. We need to go a step further. We need to go to the workloads themselves. And remember how I said earlier that we should really be learning not just what communications are traversing our network, but what's causing those communications to traverse our network. We need to go inside the workload. We need to understand that this workload is a workload that, a web server as part of this application. We need to know its role, and we need to see what is running on that workload. And we need to understand what should be running on that workload. Which processes should be running? How should the OS be configured? And therefore, what communications can we expect to see it generating? And once we have that information, we can lock that down too. Right? So now we have a picture where we've locked down the network around the application and enforcing network security policy. We've got workload level or process level security policies as well, and we're locking down the workloads themselves. Now it's starting to look a little bit more zero trust like, right? But we can't stop here either, because as we all know, applications change often, and they're changing more and more frequently, right? And it's hard to keep up. So the next part of this, step 3 of this process, is adapt. We need to be able to do this continually. We need to be able to know if a new workload is created as part of that application, and we need to adjust our policies to accommodate that. And as that workload is spun up, we need to understand how it was configured when it was conceived, and we should lock that down too, and change that as the workload changes itself. Now, this whole process of aligning zero trust to applications is something that we've been calling adaptive micro-segmentation. And you'll hear about it more if you attend Tom Gillis's keynote presentation. I think it's at 2 or 2:30. You'll hear about it in even more detail if you attend Tom Korn's keynote tomorrow, our security showcase, where he's actually going to demo this using our products, what this looks like. But essentially, what we're talking about is gaining application level visibility into our environment, using that visibility to inform security policy that we then dynamically deploy on the network and on the compute side of your applications. That's adaptive micro-segmentation. Now the question then becomes, well, why is VMware talking to me about this? VMware is not traditionally a security company. That's true. We also weren't traditionally a server company, right? We're a software company, and we did pretty well there. But how do we make this possible? So it starts with this notion of the virtual cloud network. There we go. We launched this back in May. So actually, show of hands, who here has heard of the virtual cloud network? Or virtual cloud networking? Okay, very few. Good. So we launched this as a concept back in May. And really what this is, it's not a product, it's not a SKU, you can't buy it, I'm not selling, I promise. The virtual cloud network is a vision for the way we see networking being done in the future. As we move past the boundaries of the traditional data center, out into the cloud, out to the edge, as we use different types of workloads, different types of hypervisors, we need something that can connect and protect those workloads and therefore those applications no matter where they reside. And that's what virtual cloud networking is all about. A pervasive, ubiquitous layer defined in software rather than hardware, because obviously you don't necessarily control the hardware once you move into the cloud or out to the edge even, that allows you to deliver connectivity and security no matter what. The NSX Product Portfolio is the product portfolio that helps deliver the virtual cloud network and therefore adaptive micro-segmentation. We're not going to talk about every product on here. For those of you who have been following NSX for a while or maybe use NSX, you're probably used to us talking about NSX as a single product. This year, we've turned it into a portfolio. Lots of different products make this up to deliver the vision we were just looking at. The ones that are pertinent to us today: NSX Data Center, which is the flagship; App Defense, which is the compute protection side of the equation; and Network Insight, which is a huge part of our visibility talk track. So what this looks like from an adaptive micro-segmentation perspective is this. You have NSX Data Center, or NSX Cloud for that matter, enforcing least privileged on the network. You have App Defense, enforcing least privilege on the compute, right, inside the actual workloads. And you actually have vRealize Network Insight, although it's not up here on screen, kind of in the middle there, helping out with the visibility piece. Shading more towards the NSX side, if we're being honest. So that's what it's all about. For today's presentation, I'm going to stay focused on NSX. As we said earlier, we've got a couple people who are new to the product in the room, so we'll talk a little bit about NSX specifically. But if you're curious about App Defense or Network Insight, here are a couple sessions that I highly recommend you check out this week that will give you some more information on those two products. All right, how am I doing on time? Cool. So let's talk about NSX for a second. What is NSX? It's our networking and security virtualization platform. If that doesn't sound like marketing language, if I've ever heard it. What is it? What does it do? Essentially what we're doing with NSX is taking the functional model of the hypervisor for compute and applying that to the network. So it starts with your physical network underlay, right? Nothing needs to change there. Then you have your virtualization layer built out of the hypervisor. And we don't care what hypervisor you're using either, to be honest. Although, of course, we'd prefer if it was vSphere. And what we're doing is, like I said, taking the functional model of the hypervisor for compute and applying it to the network. We're basically taking the core networking and security services, routing, switching, load balancing, firewalling, and we're representing them in software within the virtualization layer. And what that allows you to do is build entire virtual networks, logical networks in software that, because they're independent of the hardware, can transcend sites, clouds, data centers, hypervisors. We don't care. Any type of workload can live on these. It shouldn't matter, right? That's the whole point of the virtual cloud network. Shouldn't matter what infrastructure you're on. Shouldn't matter what kind of workloads you're using. You should be able to deliver these core networking and security services to them easily. That's basically what NSX is. That's what it's doing. Now, for today's purposes, we're most concerned with distributed firewalling and that functionality within NSX. Quick aside, you don't need to do entire build, or I'm sorry, let me back up. You don't need to build entire logical networks and software in order to take advantage of the distributed firewall and to do micro-segmentation in NSX. All you need to do, actually, as soon as you push the VIBs of NSX and install the product, the distributed firewall is ready to go and you can start using it. So you don't need to do virtualized routing and switching, and you don't need to do all that. It's actually relatively simple to get micro-segmentation as a use case and the distributed firewall up and running. Now, I'm a little ahead of myself. What do I mean when I say micro-segmentation? What do I mean when I say the distributed firewall? So let's take a look at how an attack propagates through a data center. I'm sure many of you already know this, but for those who don't, generally what happens in an attack in the data center is a low priority system gets compromised. Normally, it's not something particularly high tech, right? It's oftentimes social engineering or somebody getting fooled into providing a password or clicking a bad link or something like that. But that low priority system is, you don't throw all of your security on it because it's a low priority system. However, it talks to everything in the data center because, as we said earlier, we normally segment our data center in terms of tiers. Well, if that low priority system has a web server out there in your data center, chances are that web server can talk to every other web server. So this low priority system can actually talk to the majority of the applications in your environment. And that's exactly how attackers move throughout the environment. We call it moving laterally, or east-west. Now, as they're moving around, what are they doing? Of course, they're looking for credentials so that they can up-level access. They're looking for information that they can steal and exfiltrate. Or more recently, they're looking for information that they can hold for ransom, right? Ransomware. So how does this apply to NSX? Well, the distributed firewall in NSX allows us to build firewalls effectively around every individual workload in the environment in software and manage all of that centrally. Because it's distributed, with every additional, it's distributed to every, within the hypervisor, every additional host actually gives you more capacity. So as you scale your environment, the firewalling capabilities of the product actually scale with it. Now, what this effectively allows us to do, and by the way, so what we're doing is we're actually enforcing network security policy at the individual VNIC of every VM. Not only that, but because we're embedded in the hypervisor, we know a lot about the workloads that we're securing. We know things like the VM's name. We know what operating system's running on it. We know, what else? Potentially that it's the web server of some critical application, maybe something that falls under PCI. And as a result, we can define security policies based on any of those contexts. So we're breaking you out of the shackles of only, defining security policy based on things like IP or port or protocol. Now you have a lot more context, and you can create policy in a lot more different ways. For instance, you could create a PCI scope that would allow you to write the rules needed to secure PCI workloads, and as soon as those workloads are created, they automatically inherit those rules. Again, all of this is software defined, so it's easily automatable, easily flexible. And actually, Matt's going to talk a little bit about the power of that in his piece. So this is what you get with the distributed firewall on NSX. This is what we're talking about when we talk about micro-segmentation. Now, normally, at this point in the conversation with a customer, they say, Alex, that sounds wonderful. And I say, thank you. And they say, but I have no idea where to start. No clue. It sounds like a lot of rules. Sounds like a lot of complexity. I don't even know what's talking to what. So where do I start? Now, we have a lot of different options for how to next proceed. vRealize Network Insight is a very powerful tool. Matt's going to talk about that a little bit as well, I think, as a next step, right? Yeah. But App Defense can actually help as well. But for our purposes, let's talk about the native capabilities of NSX. So inside of NSX, there is a feature called the Application Rule Manager. Oops, sorry. For more information on micro-segmentation at a deeper level, check out that session by my colleague Stein. Great session. Sorry. So Application Rule Manager. Inside of NSX, there is a feature called Application Rule Manager. You may hear us talk about it as ARM, A-R-M. We love our acronyms at VMware. It's in the name. What Application Rule Manager allows you to do is effectively analyze the flows for a given application and recommend rules. And I've got a quick demo here so that you can actually see it in action. So we go to Application Rule Manager inside of our NSX Manager and vSphere. First thing we're going to do is start a session. Step one of Application Rule Manager is deciding which workloads you want to profile, right? So we would go through here, check the workloads that we actually want to analyze. And now what we're going to do is go let Application Rule Manager do its thing. It's going to go and run, and it's collecting and collecting and collecting flow information about those workloads. Now, some customers let this run for a week. Some let it run for a month. It's up to you. The longer, in some ways, the better, obviously, because you collect more information that you can then go ahead and analyze. That's the next step. So you can see here I'm actually going to do one from one that I had running for like 87 days or so in the lab. So now we're going to go and analyze this session. And immediately what Application Rule Manager is going to do is it's going to start recommending things. Here are the firewall rules it recommends you create. Here are the security groups in NSX it recommends you create. It even is going to let us know about an IP set. Now from here, what you can do is very easily publish it to the distributed firewall table. Pretty simple, all things considered. Now, I will say, most of our customers do not just push our recommendations directly to the firewall table, right? For, maybe obvious reasons, but because you want to check them, you want to make sure they're not going to break something, of course, right? We do have customers who will push them to the table in alert capacity and just kind of watch and see what happens so that they're not actually blocking traffic. But it is this easy to go in and start editing the rules at that point. And this gives you a running head start, right? Now, you do know what the flows are within your application. You do know how the workloads are talking to each other. And not only that, but you have some sort of basis from which you can then go and start looking at rule sets and actually getting you going on the whole process, right? So now, we've used Application Rule Manager to understand the flows within our application. We've started setting up our microsegments. We have a few that we've deployed. What about your existing security investments? What about the tools that I know you all have in your environments, the next-gen firewalls, the IPS systems, even your AV systems, right? What about all those? How can NSX help you get more value out of those? There are 3 features within NSX that can help you drive more value out of your existing security investments, the higher order security services that you're using today. The first one is something called dynamic service insertion. And what this allows us to do is take things like IPS or WAF or any of the next-gen firewall capabilities and insert those into your microsegments. And Matt's going to talk about this in a little bit, but the reason that's important, right, is because let's say you have 2 VMs living on the same host. If you wanted to firewall between them or insert something like IPS between them, you'd have to route that traffic all the way out of the host, all the way out to wherever your Palo box is or your checkpoint box is or whatever it is, and then send it all the way back in, right? Hugely operationally inefficient. And Matt, again, is going to talk a little bit about the practical applications of that in a minute. But with dynamic service insertion, we can insert that Palo service into the microsegment. We can give them the same level of control and position, physical position in the stack that we enjoy, that makes the distributed firewall so effective. We can also chain services together so that you can run them one after another and create workflows. And we also have this notion of agentless antivirus, which is a little bit different, leverages guest introspection, where we can actually offload the agents, the AV agents, from your VMs to the hypervisor and allow the hypervisor to do that work. So now you're gaining all of the value out of your AV, but you're not taxing your VMs with the operational head load, the operational load that those AV agents cause. And not only that, but the AV can integrate with NSX to actually do some automated remediation too, or automated response, I should say. So AV can use NSX to, if it detects something, quarantine a workload or something like that. Or insert some other service, increase logging, do some IPS, whatever it might be, right? A lot of value here to help you realize more value out of your existing investments. And I'm sure at this point you might be asking yourselves, who do you integrate with? I'm glad you asked. Oh man, sorry. If you're interested in learning more about service insertion specifically, there's a great session this afternoon. My colleague Rod Batchelor is going to do it on this topic, and he's going to get into the weeds, show you exactly how it works, etc. Now you might be asking, who do you integrate with? We've got some awesome partners out there. So if you are working with any of these companies today and you're curious how NSX can help you get more value out of the work you're doing with these companies, talk to your rep, come find me after the session, and we can talk through it. All right? With that, I'm going to stop talking. I'm going to let Matt come up here and tell you a little bit about what he's doing in his environment. Thanks.
Okay. So as Alex said, I'm Matt Tilley. I'm the Chief Enterprise Architect within Group IT at Kinetic. A little bit about me. I've worked in IT for about 20 plus years, 13 of which have been at Kinetic within the IT department there. And I've worked my way up through operations into management and realized that wasn't for me. So went back into technical, and I've worked through architecture up to EA role now. For those of you who might not have ever heard of Kinetic, we started out as a UK-based organization. We came out of MOD about back in 2003, I think 2004, and we are now a global defense and aerospace primarily organization. Everything we do pretty much works around security. We work now with government and defense organizations all across the world. Just to give you a bit of an idea about what we do, I'm just going to run a quick 40-second video. Oh, sorry, wrong button. If it's going to play.
At Kinetic, customers turn to us when they need help to meet their most pressing science and technology challenges. Our people have unique know-how and experience, solving problems, pushing our customers forward. The distinctive facilities we operate provide the environments to test existing capabilities, make new discoveries. Kinetic. Brilliant scientists and engineers, unique facilities, world-class expertise.
So I hope that gives you an idea of the kind of things that we do. There's all sorts of weird and wonderful stuff. Security is obviously very key to what we do. So going back to the reason why I'm here, and I promise that's the marketing over, but that's made my marketing team very happy. So 2-3 years ago now, we kicked off a project to look at our virtual hosting platform, which at the time was rapidly coming to the end of its life. It was about 4.5-5 years old. We had a number of challenges that we wanted to overcome as part of the replacement of that platform, not least of which was the complexity of the networking infrastructure that we had. I'll come on to it in a minute, but it was kind of loosely termed micro-segmentation in hardware, which is as horrible as it sounds. We also had an ongoing challenge with our platform where we were constantly fighting the battle of scaling our compute capacity, then our storage capacity, then our compute capacity, then our storage capacity, and occasionally our networking capacity as well. So that was a big thing that we wanted to overcome as part of the replacement. We have a challenge due to the nature of what we do. We have duplicate platforms, so we run at different security classifications. So we wanted to make something that we could either operate in the same way across both platforms, or ideally we could collapse into a single platform, which is still our aim, although we haven't quite realized it just yet. And due to the complexity of the environment and the security requirements that we had, provisioning of anything was a very slow and mandrolic process, which I'll come on to in just a moment. So we started from a platform which consisted of VMware, as I said, hardware, micro-segmentation, loosely termed, UCS, Blades and Dell powered servers with NetApp storage, so very traditional infrastructure. And after a fairly lengthy product evaluation exercise, we decided upon staying with ESX, bringing in NSX, and then we looked at decided upon the hyperconverged platform using HPE SimpliVity, and brought in some extra capabilities around there. And as well as replacing all of these different components that are on the slide, we had to replace a lot of the management and monitoring capabilities that we had as well in order to be able to run this as a platform. So I'm sure you can get the idea that what we were doing was a huge change to our environment. So we needed to try and make it as manageable as possible for our operations team. So a little bit more around micro-segmentation in hardware idea. So this very old diagram now is basically what we implemented back in 2007, where each of these pods, as we called them, on the boundary of this internal routed network was specific to an application or service, and it was a virtual firewall context on a physical firewall. All the rule sets were all independent from each other, so as we layered up more and more and more and more services, we had more and more things to actually manage. And due to the way that it was deployed, the ability for us to actually automate any of this was incredibly difficult, and we have never found a way to do it, even now. But to give an idea, so one of the basic principles of the environment, looking at that idea of least privilege, was that there are no implied rules whatsoever. So if the server at the top wants to talk to the server at the bottom on this diagram, it would need a rule in its own tier to allow its traffic to pass into its pod. It would then be routed across to the destination pod, at which point it would hit another firewall that is entirely independent of the first one, and it would have to have an allow rule to permit that traffic to pass to the destination server. So from the point of view of our ops guys missing configuration, it was an immensely painful thing. It's very easy to configure one side and not the other, or get something subtly wrong. So it was a hugely mandrolic process, very, very admin intensive. And as I say, we had no ability to automate any of this. Considering that this was developed or designed back in 2007, we hadn't virtualized our data center in any large scale at that point. But in 2010, we then introduced virtualization into this world, which made it massively inefficient due to the effect of tromboning, which Alex touched on a minute ago. But I just wanted to take a second just to have a look at that in a little bit more detail in case you don't understand it. So looking at this diagram here, if the virtual machine, the light blue virtual machine on the left-hand side there wants to talk to the green virtual machine on the same host, all its traffic would have to pass down through the vSwitch, through a hypervisor, out of the hosts into the physical network, into the core switch, and hit the core data center firewall, which is a physical device, at which point it might say no, in which case all that traffic was wasted. If it says yes, it then goes straight back up into the core switch, back up to the host, and then into the virtual machine that is alongside the machine that the traffic originated from. So massively inefficient use of the hypervisor and the host and the physical networking, and it means that your core data center firewall is a massive device, very, very expensive. So how does NSX change that? Well, it kind of inserts this layer here in the green. So to take the same example, if the light blue machine wants to talk to the green machine next door to it, the virtual distributed firewall is actually applied at the VNIC level. So if the decision is no, this traffic's not allowed to go, the decision is made before it hits anything at all. So from that point of view, the traffic that is leaving the machine is only the traffic that is permitted. It then passes down into the NSX layer, and then you've got the distributed logical router, which is going to make that decision as to routing it across onto the right network, and then it's going to pass it straight back up to the green machine. So you haven't even touched the physical level at all. There's no impact on the physical network whatsoever. If it's passing across to the other host, it's going to then go across the transit network and up to the right machine on the other host. So what does that really give us? Well, it gives us massive efficiency over the use of the physical network. It means that all of the decisions are being made at the virtual machine level. And because we're using NSX, all of the configuration is centrally managed. It's all in one place. We aren't in that world anymore where we've got all of these different pods all over the place that we have to manage independently. And it gives us the ability to automate, which I'll come on to in just a moment. So from the physical networking architecture, what we ended up with is this model here, which you may be familiar with, which is called a leaf spine. With NSX, we've implemented the leaf edge, which allows us to have that hook into the data center core. Everything then traverses into the NSX environment and into the rest of the virtual hosting platform. But this makes it massively scalable. So based on the infrastructure we've already deployed in each one of our data centers, we can deploy up to, I think it's 16 racks. Each rack's got 15 physical hosts in it, which, if my calculations are right, is about 240 virtual hosts that we can deploy before we need to deploy this again. So we've got huge capacity, bearing in mind that we have this in 3 data centers. So just to kind of summarize a little bit, we started from this legacy environment, traditional architecture, micro-segment hardware, kind of nightmare, to be perfectly honest. Give you some idea of the scale of that, there was 60 firewall contexts across 3 sites, around 1.2 million firewall rules that were all manually managed and no ability to automate. The result of that was we could deploy a virtual machine in less than 20 minutes, but because it couldn't talk to anything, to get it up and running and actually taking on a service would take us around about 2 days, which isn't particularly efficient. With the world that we're now in, with NSX deployed, we are now looking at far less admin intensive management of the environment. We've removed that whole tromboning effect, so NSX is now containing the network traffic, so we get far less latency when machines are talking to each other. We can automate provisioning, and we are looking at the moment at how far we can collapse that old legacy network environment. But in real terms, we can now get to that holy grail that we started with, which was we wanted to deploy automatically. The new platform can deploy a virtual machine in around about 20 seconds, a bit of an improvement on its own, but we can now have that up and running in around about 30 minutes using automated scripts to do AD join and WSUS and those kind of basic things that we want to do. And we can apply security policy based on factors like what network you've connected the VM to, or the virtual machine's name or part of its name, or for more specific stuff, tags that you apply to the virtual machine. So you've got a lot more control over that security policy configuration and application. So some of the things that we've done, as I say, that dynamic policy-based access control from an NSX point of view is hugely beneficial to us, makes us an awful lot more efficient. But we've also found that we can automate an awful lot using PowerShell. There's a Power NSX module that you can install, which gives you a huge amount of capability within NSX that you can control from PowerShell. And we capture everything into Splunk, so we can visualize it, and we can make that visualization of what's actually happening on our estate available to the whole of our ops team rather than just the network guys or security guys. So moving on to our migration, so the biggest challenge that we had during this entire project, and bearing in mind this has been like getting on for about a 2-year project, the biggest challenge that we had was convincing people that it was A, possible, and then B, that we could migrate to it. If we'd taken our traditional approach of migration, we would have ended up probably taking about a year to migrate our virtual workloads onto the new platform. So we had to come up with something a little bit different, a little bit more radical, and we worked with VMware professional services guys to determine a way whereby we could actually migrate our workloads all day, every day, if we chose to, without any service disruption. And the way that we did that was to use, as I say, PowerShell to actually do a cross vCenter live migration of running virtual machines during operational hours without actually taking the service out. Now that as a concept was quite tricky to sell to people, especially the IT function themselves. So we came up with this rather simplistic slide, and it is incredibly simplistic, but basically this is where we started. That's the traditional infrastructure. We built a completely brand new set of infrastructure with a brand new vCenter and NSX all deployed, and then using we established what's called a layer 2 bridge, and then using PowerShell, it will do a automated storage vMotion and vMotion cross vCenter without taking out the service. And in real terms, we would lose a single ping on those virtual machines during that process. Once you've done that, obviously you've got to clean up, so there's a removal of the layer 2 bridge and tear down of the old environment. But this is the migration approach. And the last bit, as the VMs hit the new platform, was the virtual distributed firewall would then kick in. So what we've done is we've actually taken our rule set from our data center core firewall, and we've done analysis over each of the different networks that we're working in as we're migrating them. And we've automated the creation of security policies using Power NSX, and we can actually inject that into the platform as we go, so those rules start to apply from the point that it hits the new environment. So a quick rundown of kind of how we got on. What went well? Automating was fantastic. It was, it completely changed the way that we approached this project. We had a brilliant engagement with VMware on the professional services side around the NSX design, and the thing that made that really different to what we've done in the past was we brought them in alongside our solution architects, and they worked with us to design the solution that fitted our environment, which is, is exactly what we needed to do. We took the role as the system integrators, which was a little bit risky, but it gave us a lot more control, certainly of cost. And a big thing for us is how to operationalize this. So we involved our operations team literally on day one of the project. We sold the idea to them, we kept them on board all the way through. We put them out onto NSX training. They all went through the official training course, and then they revisited it later on in the project lifecycle as I think it's called the fast track. I don't know if it's still available, but there was a fast track training course which was about 2 days long. So they had that initial training and then a reminder, and then as part of the project we built a lab environment which gave them everything that was in production in a lab, and they could play with it and do whatever they liked. As I say, we demonstrated this, so that demonstration that we gave, we had to repeat 3 times to our IT community. First time, everyone went, wow, that looks great, but don't believe you. Second time, people started to engage, and third time, actually, people were on board a little bit more. However, we still ended up having to go through the full change management lifecycle, or process rather, and arrange downtime during a maintenance window for the first virtual machines to migrate. But we did them online, and when they saw that actually they went across without an outage, people got more confidence and they started to engage with it as a process. I'll come on to the last one in just a sec. So what didn't quite work, we had some professional services engagement where we tried to define a deliverable, and that didn't really work for us. We had some issues around the initial sizing of the environment. The idea around hyperconvergence and some of the storage efficiencies that we could get was a really tricky thing to calculate, but we've right-sized that now. That's working really well for us. And the bridging idea, because of the complexity of our network, we are running way too many layer 2 bridges during the migration phase, which probably won't be so much of an issue for other organizations because of the nature of our micro-segmentation and hardware idea. But the big thing for me is the return on investment. So the reason why we did this, we ummed and ahed at the start of this project about whether or not to go wholesale into public cloud. And we decided after quite a lot of analysis that really wasn't the right thing for us to do because of cost and the inability to actually control that cost. And to give you some idea, the return on investment of this as a project, which is a multi-million-pound, multi-year project, has been 13 months, which I think is quite remarkable compared to us taking that straight out into public cloud. So what are we doing next? So we're looking now at the idea around the automation piece. We want that automation, orchestration, self-service, private cloud capability. Our development community are really absolutely badgering the hell out of us at the moment to try and get all of the different capabilities available. And we're working with VMware to understand how we can leverage VMware Cloud on AWS and hybrid cloud extension and some of the other capabilities as well to actually take what we've already done and really make it work for us as an automated capability. And that's it from me.
Awesome, thanks, Matt. Appreciate it. So yeah, really appreciate you being here and talking us through all that. It's a phenomenal, it's really cool to see. I've really enjoyed kind of getting to know your environment and you guys as we've been talking through this. So a couple closing thoughts here. I mean, ultimately, this is what it's all about, right? From a security perspective with respect to NSX. It's about making your lives easier to do more security and have better security than you've ever had, right? Going from here to the point where you can understand where your applications are and how they're communicating, to the point where you can use that insight to lock it down, to the point where you can get to, where you can insert third-party services and get more out of your existing investments. And then of course extend that out, or in, I should say, to the VMs themselves and the workloads themselves and lock those down too. And ultimately, this is where we want to help you get in your environments. So if zero trust aligned to applications is what you're after, if you want the pinnacle of security in your environments, we're committed to helping you get to this image. I'm not going to stand up here and talk more about this stuff. There's lots of other great sessions out there. In fact, I highly encourage everybody to check out the keynote that's literally going to be across the hall in, I think it's room 50 at 2 o'clock, where Tom Gillis is going to talk about everything that NSX is doing across the board, but he'll also talk quite a bit about adaptive microsegmentation. And then again, there's another session tomorrow. Again, I think it's 2 o'clock and it's in the room across the hall, where Tom Korn is actually going to demo adaptive microsegmentation. So you'll actually get to see App Defense and NSX working together, where App Defense is actually helping to profile the applications, create policy on the VMs, and then orchestrate policy within NSX itself so that you can deploy network security policy too. With that, we're happy to, I think we've got a couple minutes to take a couple questions. So yeah, if you have questions for me, feel free. I've got 3 t-shirts that I'm happy to hand out to question askers. And of course, feel free to ask Matt questions too. I don't mean to put you on the spot, but I'm going to. So I do mean to. Any questions? No.
What was your strategy regarding how to assign tags and security groups? I mean, where did you start? Because it's a humongous job of designing a strategy of assigning all those tags to all those new VMs that you migrated from your, let's say, legacy infrastructure to the new infrastructure.
As far as our strategy was concerned, we started with some analysis over the common rule set. So one of the slides that Alex put up earlier was around the shared services kind of thing. So that's a great place to start because everything needs to talk to shared services need to talk to everything. Bringing in some of the more discrete aspects of it. So there's still some commonality around things being able to talk to, I don't know, database services or Exchange or those kind of things. But very quickly we got to that point where actually no, we need to analyze the rule set that we've had applied at our physical layer. And unfortunately that's a bit mandrolic. We wrote some PowerShell scripts to actually do some of that analysis for us and generate some of the rule sets for us. So it ended up being semi-automated, shall we say, but that kind of automation piece is really important. And we looked at Network Insight as a capability, but unfortunately for us, our budget didn't stretch to it. It's a relatively significant cost. But the kind of capability that could have given us would have made that process significantly more straightforward.
Cool. Another question?
The NSX can be extended to the physical host, the physical servers, or just for virtuals. If not, what are the other options that we can protect the physical servers apart from the physical firewall?
Sure. So we do support bare metal and physical workloads using flavors of NSX. We can also support cloud workloads using NSX Cloud. So if you have native cloud workloads, we can support those too. And actually vRealize Network Insight, which Matt was just talking about, extends visibility into the physical as well. So you can actually visualize and see traffic across physical, virtual, and even they've got a cloud application as well too. So we support physical as well. It's a great question. I actually don't know the full answer there. I believe you can transfer them, but I'm not 100% sure. Your account team would be the best person to ask. Yeah, sorry. I try to stay away from that piece. Here you go.
Okay, about the Kinetic presentation, you mentioned that you had some challenge on the sizing. How did you overcome that? Is it because you did all the sizing yourself? You didn't engage any VMware team?
So it wasn't VMware's sizing that was a challenge for us, but it was the SimpliVity platform. Because of the way that it works, it's very clever with deduplication and compression of the data at the storage layer. But because of how it works, it's totally different to the traditional infrastructure that we were used to. So we worked alongside the HPE team, and we sized it with them, but then when we applied some of the policy that we wanted to apply, that we thought we understood, but actually it turned out we didn't really, we ended up running very low on storage very, very quickly, which we re-engaged with them, and they came in and helped us to understand the policy definition much better, and now we're in a much better place. Our storage is working absolutely fine now. So.
Okay. And the NSX license, do you know how it's licensed to the VMware team? How is it licensed?
Just in general, so
Yeah.
there are a number of ways that you can purchase NSX, but it's essentially per vCPU. That's the most basic way to think about it. Perpetual licenses, but I mean, again, there are options. So the best way to learn more about pricing, we actually have a resource that talks through it, but to ask your account team is the ideal way to see which would be the best way to purchase it for you. I think there's another one. Sorry.
Thanks for the presentation, both of you.
Sure.
The question is actually for the both of you. For you, it's more lessons learned maybe. And for you, what are the best practices considering moving away from more host-based firewalling to network-based firewalling or firewalling on VNIC? When you're migrating from the more physical world to the virtualized world. So, but you get rid of those, but you do an overlay of firewalls, host-based firewall and network-based firewall, and how would you manage that?
Uh,
You want to speak to it? Were you guys doing host-based firewalling, or?
No, not particularly. So we had the core data center firewall as I put up on the presentation there.
So is the question which way how would you do both if you wanted to, or how would you coordinate them, or?
Look at it more kind of layered mode. So you would have your host-based firewall rules, virtualized or physical, and your network-based rules. They work in tandem, right? They cooperate. So how would you implement that in your migration?
So from our point of view, we're not looking at host-based firewall. If you mean things like Windows Firewall or IP tables and that kind of stuff, we're not looking at that in particular, because we can do all of that in NSX, and we can do it at a policy level dynamically. Whereas if you're looking at Windows Firewall or IP tables, it's a far more manual thing. You can do some group policy stuff, but it's still going to come down to being a lot more difficult to manage. Than leveraging the sort of automation capability that we've now got in NSX. And because for us, NSX is effectively, it's in the hypervisor, so it's as good as out of band, so it's kind of like having your data center core firewall, but everywhere. So whereas your host-based firewall, that if you get compromised, it could be vulnerable, it could be reconfigured locally or whatever and overridden. So it's a much more complete solution for us to have it within the NSX layer.
Single point of failure.
Yes, it's a risk that you take, but I think it's a calculated one personally.
Any best practices?
So any perspective on it? I mean, it depends. Kind of depends on the environment. We have some customers who see it as a single point of failure or use it as a single point of failure, depending on what other systems you have in your environment. It doesn't necessarily have to be. but it really depends on how you architect the environment. In fact, I noticed Dennis Moreau is here. So for your particular environment, he's sitting right to your right there. He's one of our security architects. So he might actually, based on your environment specifically, be able to give you some more information about what the best way would be to do it. But yeah. So unfortunately, I was getting the flag. We're out of time, but I'll hang around. So if I know there are some other questions, so feel free to come up and ask. Thanks, everybody.